Hey everyone, Chang here and welcome to my channel. Today we're going to do something a little fun. We're going to focus on a specific shortcut in terms of multiplication. And I'm talking about multiplication of 11. Now, the multiplication of 11 has this very fun and kind of odd shortcut that I'm going to show you just through the demonstration of these two problems first. First and foremost, with these two problems, I'm going to solve it like you would normally solve it in a regular math class, using the quote-unquote standard way of multiplication. So, first and foremost, let's just look at 32 times 11. Alright, well, we start off with just multiplying all the way in the right-hand side. 2 times 1 is 2, and 3 times 1 is 3. Cool. Right? And of course, they tell you to put the 0 to make sure that, you don't forget the place. Then you do this now. 2 times 1 is 2, and you have 3 times 1 is 3. And there we go. Then we add the end result. We have 3, 5, 2. Okay, so that's the answer for this guy. Now, for this one, same process, right? 8 times 1 is 8, 7 times 1 is 7. Put the 0 as a placeholder. Then you do 8 times 1 is 8 again, and 7 times 1 is 7, and then you add them together. And what do you get? You get 8, this one is 15, so it's 5, 1 right there. That's going to be 8, 8, 5, 8. Okay, cool. So, that's how you would solve a multiplication of 11 normally. Now, here's the thing I really want you guys to focus on. After you go through the process, notice this right here. And this right here. Right? So the in-between seems to be just the adding of the two digits, right? So you have 3 and 2, so you have 3 and 2 here. You're going to add them together. That's what's going to be the end result. Now, 7 and 8, you have 7, 8 here. That's sort of the end result. Technically, there's a 15, right, when you add them. Now, the other thing I want you guys to notice is this. Well, other than adding the digits itself, the two digits, the ones that are multiplying 11, is actually to the side as well. In this case, it's a 3 and 2 right here with the 5 in the middle. This one, it looks a little odd, but technically it's 7 and 8, right, with a 15 in the middle, so that when you add them all together, you have actually 8, 5, 8, and that's what the final answer is. So, does this apply almost all the time? Actually, interestingly enough. And there is a complicated, like, sort of generalized proof or reasonable explanation for this, but actually I think it's just really cool. The best thing to remember, especially when you're multiplying two-digit number, is you split the two digits aside and then you add them, and that's the result in the middle, right? So, we're gonna do that first. Let's just practice this skill. And then what happens if we multiply a three-digit number and 11? And you're going to realize, interestingly enough, it's actually very similar. So let's just take a look at it. All right, so here we have 3 different problems where you're using a two-digit number and you're multiplying it by 11. Now, once again, you can solve it in the regular way possible, and you can use a calculator if you want to verify, or you can just use your little hint. Now, remember this. First and foremost, when you look at it, you're looking at the two digits, right? Then you're separating them. It's just going to be 4 and 3. And then whatever's in the middle, that missing number is the sum of the two. In this case, it is just 7. So the final answer is actually 473 for this one right here. Now, this one, let's do it again. We're looking at these two digits. We're going to separate them first, which is going to give us 8 and 6. Now, when we add them together, though, it's a little different. When you add 8 and 6, that's 14. So we're going to write 14 like that. And then afterwards, we're going to combine it. 6 is still the same. This is actually going to be 9 now. And this is going to be 4. The 9 is these two right here. And the 14 was the original 8 plus 6. So total 946 is the answer for this one. Same logical reasoning. These two digits. So we have 9, 8, and we need something in the middle. Well, 9 and 8 is 17. Cool. So we just bring it all down. This is going to be 8, 7, and this one 9 and 1, 1, 0. There it is. So this would be the answer for this guy. Very quickly. A lot quicker than if you just multiply it through the regular method. Alright, so now we have three-digit numbers multiplying 11. What do we do, right? In this case, you can't just split numbers because guess what? It's 3. It's odd. What the heck? So, interestingly enough, it's actually very similar. So what you do is you get the 2 outer digit and you still split it out. You have a 3 and a 4 right here. But in between here, there's actually going to be 2 numbers. The first one, this first number that's going to be missing is going to be 3 plus 2, right? 3 plus 2. The second one, you can sort of guess, it's just going to be 2 plus 4. So notice what's happening. What we're going to do is we're going to add these guys right here first for this side, then these guys right here for this guy. So 2 is shared in between the 3 and 4. So in the end, what we have is going to be 3, and this one is going to be 5, this one's going to be 6, this one's going to be 4. So the final answer is 3,564. So very similar to the first rule where we're multiplying 2-digit number, now we're multiplying 3-digit number. So let's look at this one. Once again, we're looking at the 2 outer digits. And we're going to have it split. It's going to be 6 and 2, and then now we have the 2 inner one. The first one's going to be 6 and 7. The second one is going to be 7 and 2. So 6 and 7 is actually 13. So I'm actually going to write it like this, right? And the other one's going to be 9. So let's just put 9 right here. So in that case, what do we have? 7, 3, 9, 2. And there we go. That's the answer for 672 times 11. Same reasoning, and hopefully you guys can get this very quickly right now. All right, so we have 6 and 6. Split them up. 6 plus 7 is what? 13, right? So we have 13 here. Oh no. And then what? 7 and 6, we have 13 again. 13 here. That's the odd one, right? But I want you guys to see it anyway. So you guys, it's sort of staggered, right? In this case, what do we have? 7, 4, 3, 6. And that is our answer right there. And just to verify, if you're not sure, you could just keep adding 11 from 672 to 676, so basically plus 44, right? And then you should have the same answer. All right, so there you have it, multiplication of 11s. Now, we have the single digit, which you guys should be familiar with. Now we have double digit, which is fairly simple. We have triple digits, which is still quite simple. Of course, there's more and more, right? There's the, 4 digits, 5 digits, so on and so forth. And you guys can explore and try to figure out the pattern. Hopefully this gives you somewhat of a clue on what to do. Just a fun little trick. Only works with multiplication of 11 because the special property of the fact that 11, you're carrying numbers because they're all multiplying by technically ones in different, I guess you say 10th place, right? So hope you enjoy this. Thank you for watching. Please like, comment, and subscribe. I will see you in the next video.